Hi there. Today we're going to talk about mathematical modeling, and the first topic I'm going to discuss, and I'll discuss several different mathematical models in this particular lecture. The first one we're going to discuss is consecutive numbers. Consecutive numbers are numbers like, let's say, 3, 4, 5, 6, etc. Numbers that come in order. And anytime you're working a problem like this, if you'll let the first number that you're thinking of be x, then relate each of these to x. So the next number in a consecutive sequence would be x plus 1. And the very next number would then be x plus 2, and then x plus 3, and you get the idea here. Sometimes they're going to ask you about even consecutive numbers. So let's just look at a list of even numbers. Let's say we'll start at 8. The next even number would be 10, then 12, etc. So if I let the first number once again be x, the very next number in this even consecutive number list would be x plus 2. And the next one, x plus 4, and the next one, x plus 6, and so on. Sometimes they'll want you to talk about or try to find some sort of problem involving odd consecutive numbers. So let's look at the list of odd consecutive numbers. Just some random list. Let's start with, say, a 5. Then the next one would be a 7, 9, etc. If the first one we call x, then the very next one would be x plus 2. And the next one x plus 4, etc. Alright, next we're going to do a problem involving these consecutive numbers. Alright, my problem that I chose is the sum of 3 consecutive numbers is 804. So if we wanted to list this out in a mathematical model, we'd start with the very first number. That would be x. And this is listing 3 consecutive numbers. So the next number in that list would be x plus 1. And the next number would be x plus 2. And there's my 3 consecutive numbers summed together, and this sum is, and is in math, usually means equal to 804. So I'll just perform the algebra manipulation on this. I have 3 x's added together. That gives me 3x plus 3 equals 804. I'm going to subtract 3 from both sides, and I'll get 3x equals 801. I'll divide both sides by 3, and I'll get that x is, let's see, 3 goes into 8. 2 times 20 would be 6. 18, 21, okay, so I think the first number would be 267. Now, they wanted me to find all 3 numbers. I always need to make sure that I've answered the question. So, if the first number is 267, and the next number, I'll just write them in a list over here to the side. It would be 267, then 268, and then 269. And if I were to add up these 3 numbers, I should see that their sum is 804. In working with percent equations, we have a few key words that we are going to naturally be dealing with. When you see the word is, think equal to. That's usually what it means in math and in percent especially. When I see the word of, think multiplication. And then anytime you see a percent sign, change your percent sign to decimal form. That's one of the things you need to remember in working with percents. Alright, the first percent problem we're going to do is swimming pool problem. And we've bought a swimming pool, and the swimming pool itself has been discounted 15%. And this sale price is $1,210. And we would like to know what was the original price of the pool. So in order to figure out what I'm going to do first, I think to myself, well, what are they looking for? And they're looking for the original price of the pool. So I'm going to let that be X. X equals original price of my pool. Now, in order to calculate that sale price, what they did was they took 15% of the original and then they subtracted it. So we took our original minus 15% of that original, and we got $12.10. And this is how I'm going to set up this particular problem. Understand that there is a 1 understood to be here. Some of you like to write that in. That's okay if you do. And 1 minus 0.15 is 0.85. In other words, you're paying 85% of the original price of the pool. In order to solve this, I'll divide both sides by 0.85, and I plug that into my handy-dandy calculator because I don't want to do this one in my head. And when I plug that into my calculator, I do 1210 divided by 0.85, and I would get $1,423.53. All right, my next problem is a dimensions problem. And anytime I'm given a dimensions problem and it tells me I've got some sort of shape, I usually, well, always will draw that shape so I can figure out what in the world they're talking about. So it says I have some sort of rectangle because I have a picture frame and I know what they look like. They tell me that the total perimeter, that is the total distance all the way around, if I were to walk all the way around this picture frame, the distance around would be 3 meters. That's what perimeter means. The height of the frame is 2 times its width. So if I call this the width, this height is 2/3 its width. Now this laid it out very clearly. It says 2/3 times its width. Sometimes they'll say 2/3 of its width, and if they say that, just know that of means times again, and you can calculate it exactly the same way. In order to find perimeter, I walk all the way around, and if I walk all the way around this, I'll see that I walk 2 of these W lengths. So 2 of these W lengths plus 2 of these widths, or widths and lengths, whatever. 2 lengths, 2 widths. And this total should be equal to 3. So I'm going to do this little calculation here. I have 2W plus, I'm going to do this multiplication. This is the same as 2 over 1. So I'm going to write 4/3 W equals 3. Now I'm going to use a technique that I learned in the previous section to get rid of my denominator so I don't have to fool with getting a common denominator. I'm going to multiply both sides by, oops, it's a crazy looking parenthesis, but there he is. I'm going to multiply both sides by 3. And when I do that, I'm going to distribute. I'm going to multiply the 3 times the 2W, and I'll get 6W. Plus, I'll multiply 3 times the 4/3. This is the same as 3 over 1, so that's going to be 4W, and that's going to equal 9. This makes my numbers a little prettier. Then I'll get 10W equals 9. Divide both sides by 10, and I'll find that the width, the width is 9/10 meters. Now that asks for the dimensions. I found what W was, and they wanted the dimensions. So I also need to calculate the length. And the length, we know, is 2/3 times whatever the width is. Well, the width happens to be 9/10. So I'll do this multiplication, and making it easy on myself, I'll do a little canceling first. 3 goes into 9 3 times, and 2 goes into 10 5 times, and I get 3/5 meters. So this is my length, and I'll give them a little circle so that whoever is looking at this can see that this is my length and this is my width. Now whoever's grading this will be able to look at it and know that I know the dimensions of the picture frame. All right, now this problem's pretty wordy. It says we have an executive and he flew to a meeting 1,500 kilometers away. After traveling the same amount of time on the return flight, the pilot mentioned that they still had 300 kilometers to go. The airspeed was 600 kilometers per hour, and they would like to know how fast was the wind blowing. And we're to assume that the wind was parallel to the flight direction and it was constant throughout the whole flight, both there and back. All right, when I see a problem like this, I go to my rate formula, and I know that rate equals distance divided by time. So that's the formula that I'm going to be dealing with. On this particular problem, we have two situations. We have the to flight and we have the back flight. So I'm going to call them, how about go and coming back. And we're given quite a bit of information. I need to figure out how how each one relates to the go flight and the come back flight. So I have these variables. R is my rate. That's going to be the speed of my plane. Now on the way there, let's see, it looks like on the way there I was a little faster, so the wind must have been helping me. So my rate must have been 600 plus whatever the wind was. On the way back I was fighting the wind, and so it made me a little slower, so that must be 600 minus W. And I'm allowing W, I didn't state that, W equals the wind speed. I should have said that. Okay, so the distance. Well, the distance there and back is the same, but that's not really the information that they give me. The information that they give me is I have 1,500, and then they tell me that that's the total distance. Well, I know that that's the go. But they relate this problem in terms of time because they say in the same amount of time. So look for the thing that's equal. So this is the thing that I want to be equal is my time. In the same amount of time, I went 300 less than 1,500, so I must have gone 1,200 miles in the same amount of time. So in the same amount of time. So I look for what's equal so that I can write an equation. I want my equation based on t. So I'm going to rework this equation and make it read t equals. When I do that, I'll multiply both sides by t to get them out of the denominator and divide by r. So my equation for this is going to be t equals the distance divided by the rate, so that I can equate these two times, so that in this case I have t equals 600, oops, not 600, I went D, 1,500, I'll make that a 1, that's a 1, 1,500 over 600 plus W, and then this one will be t equals 1,200 over, because that's my distance divided by my rate. My rate is 600 minus W. Alright, I'm going to go over here and put these two equations together because these two t's right here, there, and there are the same. And that is the key to solving these problems. Figure out what is the same and equate those two. So since these two times are the same, I can say that 1,500 over 600 plus W equals 1,200 over 600 minus W. And once I have this, then I just have little algebraic manipulation to do. I'm going to do a little cross multiplying, or you can say I multiply both sides by that amount. 1,500 times 600 minus W equals 1,200 times 600 plus W, and running out of room. I'll distribute. Alright, distributing and cranking all these numbers out, you're going to end up with, let's see, 900,000. See if I can. Alright, I scooted this over just a little bit and then wrote down the remaining numbers once I got my little area set up. So it's 900,000 minus 1,500 W equals 720,000 plus 1,200 W. Alright, while you're working this, you're going to subtract the 720,000 from both sides, and I'm going to add the 1,500W to both sides. That will yield me 180,000 equals 2,700W. And then when I divide both sides by 2,700, I'll get that W is 66.7 kilometers per hour. Alright, now that concludes this part of our mathematical modeling and working with some word problems. Word problems tend to give students trouble, so if you have any trouble with these, just contact me through the discussion board or the eLive sessions and we'll try to figure out where you're having trouble.